astronautics company, and he's gonna go ahead and take the floor. Chris, are we good to start?
Great. I just started recording, so take it away.
Okay, wonderful. All right, Dr. Zubrin, the floor is yours.
Hello, I'm an astronautical engineer. I've been involved in designing space missions and space technologies for over 30 years. And I got interested in this subject when I was a kid. Space race was on, and I got myself a science education so I could be part of it, and I've been part of it. But you are living now at actually a better time to get into it, because the space program that I joined was pretty much a government program, and it accomplished certain things. We got to the moon and sent some probes to Mars. But now there's an entrepreneurial space revolution, which I'm sure many of you know about, because the leading company of it, SpaceX, is doing launches from Brownsville, Texas, not too far from you, creating a new kind of launch vehicle altogether, the Starship, which will be a fully reusable heavy lift launch vehicle. You know, we'll have the same capability as the Saturn V rocket that got us to the moon in the 1960s, except that was a throwaway rocket. This is going to be a reusable rocket, and it's going to dramatically lower the cost of getting into space, so that, you know, only 12 people went to the moon, but when Starship is operational, hundreds of people will go to the moon and Mars and beyond. And there will be many, many more space launches. You know, last year, there were 100 space launches in the whole world. You know, there are thousands of airplane flights every day, you know, even long distance airplane flights. But only 100 launches in 2018. Well, pretty soon there's going to be 200 and 400 and 1,000 and 10,000. So we're entering the real space age now. And, you know, we're going to be going to the moon, we're going to be going to Mars, we're going to be seeing what we can do to settle these worlds. We're going to be launching gigantic space telescopes that will tell us about worlds orbiting other stars. You know, you're here at the start of it. You know, learn your science and you can be an explorer of new worlds, you can be a settler of new worlds. This is the great adventure. And you know, there's nothing going on in the world today that's more important. You know, if I asked any of you what happened in 1492, I'm sure that almost all of you would be able to say, well, that's when Columbus sailed. And that's true. But that's not the only thing that happened in 1492. Many, many things happened in 1492. England and France signed a peace treaty in 1492. The Borgias, a very rich and powerful family, took over the papacy in 1492. That would have been a big headline if they had had newspapers in 1492. Nobody today knows about that. Nobody 500 years from now is going to know about Trump or Brexit or what's going on in Syria. But what we do to make their civilizations possible on hundreds of new worlds, that's what they're going to know about. This time is going to be remembered because this is when we first set sail for other worlds. Okay, so you're at the beginning, you're pressed into the creation, you can be one of the creators. And I envy you. So I'll be happy to take questions. Anyone got some questions?
I don't know if this is an entirely new group. Chris, are they? Or someone?
Yes, this is a new group. I know Progresso is new because I spoke to them beforehand. And we also have, it looks like, United South Middle School out in Laredo. And I'm not sure if you ever meet this class. If you want to either unmute yourselves and let us know what campus that is. I'm assuming that's the teacher's name. But
while we're doing that, Dr. Zubrin, I know I wanted to change up the questions, and I'd like for you to talk about your work in pioneering astronautics and what is it you do? Do you have contracts perhaps with NASA or other companies in the aerospace sector? What is, well, and go ahead.
Well, we have had a lot of contracts with NASA. We've done over 70 contracts with NASA.
Wow. That's crazy.
Well, we've been in business since 1996, so that's about an average of a little more than 3 NASA contracts a year. So, but they add up. We've done a lot for them. We've done some for the Air Force and the military. We've done some for other companies. We are basically an R&D company. We're problem solvers. We come up with inventions of our own, and we prove that they'll work if NASA is interested in them. Or in some cases, we will work out the problems in other people's inventions. But that's what we do. We're a small company. I have 10 employees. Have offices for 10, and then a lab of about equal size to that, maybe a little bigger. And we've done rocket engines. We've done high altitude balloon work. We've done systems, a lot of systems for making fuel or oxygen on Mars or on the moon or asteroids. We've done breathing systems, life support systems, waste recycling systems, all sorts of stuff. We have a good time.
What is the likelihood of mission on Mars to succeed when it comes to rocket fuel and it being produced on site? What kind of
well, actually, that's where a lot of my work has been, the ability to make fuel and oxygen on Mars. And more broadly, the ability to take materials that you can find on Mars or the moon or asteroids and turn them into useful resources. Because, you know, the thing that decides whether a place is a place you can inhabit is whether you can use the materials there, whether you can turn them into resources. They're not resources unless you are resourceful. That's what makes something a resource. You know, stranded on an island, the fish in the water are a resource if you know how to fish. But they're not if you don't. And that's how it is with everything. And well, Mars has got carbon dioxide, is 95% of its atmosphere, and it has water. It's frozen in the form of ice, but so that's water. And with water and carbon dioxide, we can make rocket fuel and oxygen to burn the rocket fuel. The easiest one to make, which has been my focus and which is now baseline for Musk's human mission to Mars, is to make methane as the fuel and oxygen as the oxidizer. And but you can make more complex fuels. You could make ethane or ethanol or methanol. You can make kerosene if you really want to. But the easiest fuel to make is methane, and which is natural gas. It's what many people use in their houses for their stoves. And it burns very clean. It makes a good rocket. And the SpaceX Starship is going to use methane and oxygen as its propellants. They're plentiful on Earth, they're cheap, and we can make them on Mars, so that instead of bringing the fuel you need to come back, you make it there.
So I know when astronauts when they're in the International Space Station, they have reduced bone density. Is that something we're going to encounter on the surface of Mars?
Well, the bone density and muscle density of astronauts on the space station are reduced because they're living in zero gravity. And, you know, if you're living on Earth, as we all are, you have gravity. And so let's say you weigh 120 pounds. Well, if you're walking around, you're carrying 120 pounds. That's what your legs are lifting every time you take a step. And that's a workout, okay? Now, and we're all used to that, so it doesn't seem like a workout, but that's just walking around doing ordinary things. Of course, if you do athletics, you get more of a workout. But even so, just the ordinary person who is not into athletics, is not into working out, doesn't play sports, but just, you know, walks around the house, walks to school, walks to the supermarket, goes here, goes there, they're getting some exercise. And you don't get it in space. And so you get out of shape. And the muscles you're not being used start thinning out. And the bones even start thinning out. Now, they have exercise machines on the space station, but just to match not not working out on Earth, but just carrying on normally on Earth. You got to work out 2 hours a day on these exercise machines just to match what you're losing by not having gravity. And a lot of astronauts, frankly, are just not that, they don't have the time for it, or they're not disciplined enough to do it. And so many of them do have their physical condition deteriorate while they're in space. It doesn't kill them, but when they come back, they're very weak. Some of them haven't even been able to walk for a couple of weeks until they get back into shape after they land. Now, that's one reason why I would like to spin the Mars spaceship going to Mars. You spin it, you create centrifugal force, you create the equivalent of gravity, and they won't get out of shape. Now, on Mars, there is gravity. Okay, it's not as strong as Earth gravity. It's about 1/3 as much. So if you weigh 120 pounds on Earth, you weigh 40 pounds on Mars. Okay, that's not that much. But if you're outside and you're exploring and you're wearing a spacesuit that weighs 240 pounds, that plus your 120 adds up to 360. Divide by 3, you're back to 120. So you're hiking around in that spacesuit, you're getting a workout about equivalent as hiking around on Earth without a spacesuit. And so it'll be easier to stay in shape on Mars than it is in orbit. But, people will have to make sure that they do.
Another question, Dr. Zubrin. So you got a bachelor's in science, bachelor BA in mathematics from Rochester, and then you went from mathematics to nuclear and aerospace. How was that transition? I know it was at a time when the Cold War was still ongoing. Did that have a play, or did you want to pursue developing perhaps rocket fuel to go to Mars and whatnot?
Well, I got a degree in math, actually, applied mathematics as it relates to physics.
The language of the universe.
Okay, yes. I mean, there are other areas of mathematics that don't have that much of a connection to physical processes, pure math. But this was applied mathematics, and I took a lot of science classes along with it. And so, actually, when I graduated college, the space program had been pulled back after Apollo ended, which had ended by the time I graduated. So there weren't that many jobs in that. I became a high school science and math teacher. And I did that for about 7 years. But then I decided to go back to graduate school, and I got engineering degrees there. Now, in some respects, I was at a disadvantage compared to most of the engineering graduate students who had engineering bachelor's degrees. And there was stuff they had learned when they were sophomores, juniors, that I had to learn quickly myself. And so, in fact, while I was taking graduate classes, I was auditing undergraduate classes in basic engineering stuff. On the other hand, I was better at math than they were. And a lot of the hard part of engineering is the math. So I had some advantages and some disadvantages. But I was able to do it, and I got a master's degree in nuclear engineering and then one in aeronautics and astronautics, and eventually a PhD in nuclear engineering, although I got that while I was on the job at the Martin Marietta Company. That is, I did that remotely while I was working.
So my brother Daniel, which I have next to me, he's going to jump in a bit and ask a question.
Hi, good afternoon all. Dr. Zubrin, so touching on this subject of education, so like my brother mentioned on the previous casting going on, that given these students are so close to the area where the Starship is and one of the SpaceX locations, we try to stress, just like you mentioned on the previous broadcast, that this is a great time. Just like when you were growing up, you were inspired, and so are these students. But I feel like a lot of times they kind of need like a guidance from someone that is in the field. What would you recommend for them to study and really try to pursue? Because I feel like given like artificial intelligence going on right now and the way that the world is shifting at an exponential rate, what would you recommend for them to possibly study and be in college maybe 6 years, 7 years from now at the age they're at, and that would be feasible for them to be pursuing and putting in their work into society?
Well, as it was in my day, I mean, there's all sorts of things you can do. I mean, you can always help take part in the space program if you're a writer. They need writers. But the core of the program is the engineering. And to get into that, you want to study all the science and math that you can. It's math, physics, biology, chemistry. And in this day and age, which was not the case then, you want to also learn how to do computer coding as well. That's a very important thing, of course, nowadays in terms of doing engineering and many other things for that matter. So those are things you want to make sure that you learn as much as you can of while you're in high school. And that gives you the most options for what you can do when you go to college, okay? And this is important because, for instance, if you don't take much math in high school, you won't be able to all of a sudden decide in college that you want to be an engineer. You will have cut that road off from yourself, okay? So there are decisions that you're going to make relatively soon that will affect your entire life. So I advise you to take at least 3 years of math in high school, if you can, 4. And then also each year take a science, physics, chemistry, biology. They're all useful. Okay. Now then when you get to college, then you have your options open. And maybe, well, you could become an engineer, and the engineers can be aerospace engineers, mechanical engineers. There's probably more mechanical engineers at SpaceX than there are aerospace engineers. And of course, mechanical engineers are very useful in all sorts of industries, so that you have jobs that you could get outside of the space program too. Electrical engineers, that's also a very important one for spacecraft and many other fields, of course. Chemical engineers to some degree. Even civil engineers, you know, building these launch facilities, you know, that's civil engineering, building structures. Now, then there are people, you know, like a lot of the scientists who participate in missions are not engineers, they're scientists. For instance, there's geologists, astronomers, and soon there'll be biologists who participate in these missions, because we're going to be sending life detection experiments to Mars. And of course, biologists are involved in designing life support systems. And of course, biology is also a very good major if you want to become a doctor, which is a career in itself, but also has a lot of use in the Human Spaceflight Program. So there you go. But now, if it now could be that you are not, you know, mathematically inclined, but there are still ways to help. Well, among the sciences, biology is less mathy than physics, for example. But also, as I said, there are, you know, any number of things one can do. One can write in any way that one can spread the vision. I mean, probably, you know, who did a lot to help us get to the moon? Walt Disney. And he wasn't an engineer at all, but he made some movies about going to the moon, and it really spread the vision. And I think probably John F. Kennedy saw one of those movies during the 1950s. And so
yes.
when it came down to deciding, what are we going to do to match the Russians? He said, we're going to the moon. Okay. So
not because it is easy, but because it is hard.
That is true. Exactly. And he gave that speech in Texas, by the way, at Rice University. But yeah, okay. Walt Disney did a lot to get us to the moon. So he was into film and storytelling. And, you know, started as a cartoonist. So there are things you can do, but you know, as I say, the thing that you could learn that would give you your best chance of participating is science, math, and engineering.
Dr. Zubrin.
Hello?
Yes, my students had a question as to what was your biggest challenge to get to your current position as an aeronautical engineer?
Well, I'll tell you. Okay. It was believing I could do it. Because, you know, you see people on TV like astronauts, and you say, well, that's great, but that's not us. That's the people like movie stars who live on the other side of the TV screen. Okay, they don't live on our side of the TV screen. They live on their side of the TV screen. All these astronauts and scientists doing missions to Jupiter and so forth. They're like movie stars. They're not part of our world. They're part of a different.
Well, they're pilots. They're pilots, right? Back in the day, they were all pilots, right?
Yeah, but sure. But what I'm saying is, you know, I'm from the first generation in my family that went to college. My father did not go to college. Okay. My father was actually an orphan who worked his way through high school selling newspapers. But he did well enough that I could go to college. And believing that I could be one of these people that you see on TV who are doing this amazing stuff. That's a thing. So, you know, but you have to realize that all those people that are astronauts today who you see on TV, they were once in junior high school looking at astronauts on TV and thinking, those are the people on the other side of the TV screen. They're not one of the people on my side of the TV screen. Okay, they were no better positioned to become astronauts than you are today. Okay, so yeah, they had to do a lot to do it, but where you're sitting today is where they were sitting when they were your age.
Do we have any other questions from any other students? Ask away.
There was a chat question. They want to know about annual salaries of, you know, any like aeronautical, astronautical, mechanical, whatever you.
Well, the salary of engineers at the low end is $40,000 a year. At the high end is $250,000 a year. And more typically, you know, in mid-career, because, you know, when like anything, you start out at the lower pay and you start getting more as you become more experienced. Right now, maybe 70, 80, 90,000 a year. So here's the thing. If your biggest ambition is to get rich, there are other fields where you can make more money. But if you become an engineer, you'll be able to buy groceries.
Well said. Just to respect your time, Dr. Zubrin, you mentioned you weren't available from 2:30 and on.
I have 15 more minutes I can do.
Oh, wonderful, wonderful. My brother has another question. Before you go.
Hi again. So okay. So I've seen a good amount of your YouTube events and excerpts of your book, because actually in honesty I wasn't fully aware of all your work, and now I'm just amazed, and it's even more impressive that we're able to share time with you, and we all appreciate that. But on a random curveball here, were you able to see the new Tesla truck which Elon mentioned that would be pretty much what they were going to be using on Mars once it was pressurized. What are some of the things that these vehicles will need when being on Mars and other planets, and like besides being pressurized?
Well, okay, well, we'll have to see how well that truck works on Earth, okay? But certainly electrical cars and trucks and all-terrain vehicles and even motorcycles will be what we use on Mars. We won't use, cars that burn fuel in air, because the air on Mars doesn't have oxygen in it. So we'll use electrical vehicles. Now, my own favorite for Mars are not big vehicles, even the size of that truck, but smaller things, the size of all-terrain vehicles, because there aren't any roads there and the terrain is rough, and so you need nimble vehicles. I think Mars is going to be explored in the saddle, and you might have ones that got a bit more muscle, so that you could attach trailers to them, so that if you did have a cargo, you could hook it up to it and pull it along. But then when you're not hauling cargo, you detach from it and you have the freedom of the all-terrain vehicle. That would be my favorite for Mars. We have, the Mars Society has a desert station, and we've experimented with different size vehicles for exploring in the desert. And in general, the all-terrain vehicle, it can be, my favorite's the one-person, but you can use the two-person. Those are okay. But when you start getting into vehicles the size of SUVs, let alone larger, it becomes a real problem, because if they get stuck, what are you going to do?
I have another question, Dr. Zubrin. What was your experience like being a science teacher before becoming an engineer?
Well, it was mixed, I have to say. And I think you guys probably know this quite well. There's good days and bad days. It's very rewarding when you have kids who get into it and want to learn it, and you can really teach something and do creative things. It's not fun, whether either because the kids are not interested, or you have a school administration that is not helpful, then it can be very difficult to do anything. The teachers, I had some time when I was a teacher when I found it very satisfying, but other times, yeah, it was a drag, and I can't. That has to be admitted. And depends a lot on how well you hit it off with a particular group of kids, and then just the general environment in the school.
I have another question. We have a lot of, well, not that there's problems, but it'd be nice if we can increase the amount of energy we can store in batteries. Currently, we rely on chemical-based batteries. What is your take on that? Like, in the future, do you see nanotechnology like carbon nanotubes and graphene and these new materials coming out to play a role in battery technology?
Well, there's a lot of work on that, and there's a breakthrough waiting to happen in that area, and that will change everything.
Wonderful. We need that.
The Tesla electric cars are pretty good, but frankly, they're still expensive compared to an ordinary car that does the same thing. And you takes them much longer to recharge than it does to refuel a regular car. You can just go to the pump, and inside of 2 minutes, you're on your way with a full tank, whereas it takes hours to recharge a Tesla. A lot of people don't like that. So if we could have batteries that, first of all, take a much bigger charge, cost less, and can be charged quickly, then everything will change, everything. And not just for cars. It means that power sources like solar panels and windmills, that are on again, off again, will be able to store that energy, and that won't be a problem. So so that is, and that of course is also something we very much want for the space program, to have batteries that hold much more charge per unit weight and have all these advantages, but especially for Earth. You know, a lot of times the space program has led to breakthroughs in technology for Earth. For example, solar power. Solar panels were first invented for spacecraft. That's where they came from. Because what are you going to do in space to make power? You can't burn coal. You can't burn that. I mean, you could bring oxygen with you and burn it, but then it's used up. The satellite wants to be up there for years and always have power. It needs to have some way it can get power. Well, the answer was solar energy, and they invented it for space. And then, of course, now it's becoming increasingly widely used on Earth. You know, a battery, you know, that lasts a real long time. You know, how about a battery that lasts a week instead of a day before you have to recharge it? How about a battery that lasts a month? You know, there's a lot of reasons why someone in space wants that. I mean, anyone would want it, but you want it even more in space where it's not so easy to recharge. And so this is why space research has caused a lot of technological advances that have benefited the Earth a lot. You know, I think they're probably going to invent ways to produce food much cheaper than we do it on Earth, and you know, even like artificial meat without having to have cows out there eating grass and then having to kill them. They just grow the food in a little can, and things like this are going to be invented as part of the space program, but which will do a lot for Earth.
Dr. Zubrin, so how close do you think we are, given your background, this is probably the best question for you, how close do you think we are to really using nuclear energy as opposed to fossil fuels, which is kind of embarrassing if alien species were to come here and like for them to know that we really get our fuel from dead dinosaurs?
Well, once again, nuclear power, we're going to need nuclear power on Mars, okay? Because while you can make fuels on Mars, it takes energy to do it. You could use solar energy, but the solar power on Mars is only half as strong as on Earth. The nuclear would have big advantages on Mars. And I think while we do have nuclear reactors on Earth, you know, the one place where they're really used in strong preference to fossil fuels is on submarines. Okay, a nuclear submarine is just a much better submarine than a fossil fuel submarine. It can cruise all around the world underwater and never have to come up. That's a huge advantage. A nuclear powered ship also doesn't have to refuel for years. On land, okay, it's much easier, well, or it can be anyway, to use fuel. That's the way to go. But I think that, well, as I say, it's a necessity for space, and it's advantageous for Earth. And I think by developing ultra-reliable systems for space, we'll be able to put away the fears that many people have about nuclear reactors for use in power generation for cities and everything. So that's another way that space technology is going to benefit the Earth.
Dr. Zubrin, another question. A few years back, I was looking at a lot of documentaries and nuclear research, and there's this one thing that stood out called thorium. And it's 3 times more abundant than uranium. Do you think that's a viable resource to use for nuclear energy?
Well, yes, it is. And in fact, we've had thorium reactors. We had a small one that was commissioned in 1977 at Shippingport, which is in Pennsylvania, and is actually the place where we had the first civilian nuclear reactor with uranium in 1957. So this was a demonstration that was done by the Carter administration. And yes, thorium is much more widespread than uranium, and it can be used to fuel nuclear reactors, and it has another advantage, which is that it's extremely difficult to breed bomb materials out of a thorium reactor. That is, a thorium reactor is much less useful for people who would like to make nuclear bomb material than a uranium reactor is. So in terms of having nuclear reactors that would be safe to sell all around the world, including to countries that, you know, maybe might go in a bad direction, you know, it's safer for that purpose, yes.
So do you think artificial intelligence, because this, I haven't you're not aware, but what we do, we go across the South Texas and we host robotics camps for students. Last year we impacted around 1,050 students, and we talk a lot about these newer technologies, talk a lot about artificial intelligence and how that's going to play a role in the future. And Elon Musk talks a lot about that. In fact, he developed the whole company around that. What do you think artificial intelligence will be replacing our jobs more so in the future than it is now? And should we be afraid of it?
Well, artificial intelligence, okay, first we had labor-saving machinery, okay, and then robotics, and now artificial intelligence, okay. These are all ways to augment human labor power, okay. You know, well, when I was a kid, there were people who had jobs as elevator operators. That is, the elevators were not automatic, and you actually had to have a pilot for the elevator. So you would go into the elevator, and there would be a guy there manipulating the controls to take people up to certain floors and then slow it down so it would stop at the 4th floor like you wanted to, and then make the doors open and make sure everything was right, and then you go out. And can you imagine this? Having elevator drivers. Okay. Now, of course, the elevator itself saved you from having to walk up the stairs. Okay. So that was labor-saving machinery, and especially if you were bringing big packages up to your apartment, it sure was a good thing to have an elevator driver and all. But now, of course, I haven't seen an elevator operator in years. You go into a building with an elevator, you just go and push the button, it takes you to the 4th floor, and it goes exactly there and opens up, okay? So these are smart elevators. So labor-saving machinery is a great thing. Now, to me, a robot is just another kind of labor-saving machine. And well, okay, you say, well, they have automatic elevators now. What happened to all those people who had jobs as elevator operators? Well, they found other jobs, more interesting jobs to do. I mean, really, you know, is that really what you want to do with your life, is be an elevator driver? You know, there was a time, actually, you want to go way back in time.
Okay. Teacher, anyone? This is your last call for the dance. You are attending or want to attend the dance. This is your last call. Please make your way to the gym.
Oh, somebody is just, all right. Well, the water wheel, okay, was invented during the Roman Empire, okay? And before there were water wheels, people had to grind grain by hand. Okay, that is, the grain would come from the wheat. It'd still be in the seeds. And in order to be able to eat it, you have to grind it. And this was typically a job for girls would do it. They'd wake up very early in the morning and they'd have these stone dishes and stone things, and they would grind the grain up so that their mothers could cook bread that day. Okay? And around the year 100, the water wheel was invented. And then you could have machinery powered by flowing water that would grind the grain. And there's a Roman poet who wrote a poem about this, about how remarkable it was. And now all the girls are sleeping in late, you know, or because they don't have to get up early in the morning to grind the grain. So, you know, machinery has liberated us from all sorts of uninteresting jobs. You know, so.
And that's exactly what I wanted to get at, that because of artificial intelligence, because of automation, we're going to have an exponential growth in the number of jobs. So you may not be the one that's going to be putting a sticker on a refrigerator, right? But you're going to be now programming a robot, designing new shipping lanes, designing new ways to use that new technology. And so it's like when they said back in the day, we're like, oh, you know, we have, you know, this kind of new technology, we're not going to have any more patents, right? We're not going to have as many patents, but, and for example, the calculator came out and we landed on the surface of the moon with the power of a 4-function calculator. We now have a lot more processing. We carry more processing power in our pants and our hands than NASA used back in the 60s and 70s. So new technologies develop new jobs and an exponential growth.
And with that, I'm going to have to go because I have some place I have to be. But thank you very much. And once again, I've got several books that people might want to look at. One's called The Case for Mars. And that was written, the first edition, well, 96, and another revised edition later. And then my most recent book is called The Case for Space, and it talks about everything that's going on now. All right.
I want to read that one.
All right.
Thanks for your time, Dr. Zubrin.
All right. Thanks a lot. Good luck with everything.
Dr. Zubrin, thank you very much for your time today, both morning and afternoon session.
Okay.
Happy Thanksgiving.
On to Mars.
Yes, sir.
On to Mars. Thank you, Christopher. Students, thank you for your time. We're pretty much going to wrap things up. He gave us a little bit more than 30 minutes. I'm happy for that. And hope to see you all soon in robotics camps. We are going to be starting around December 5th, starting those camps, and we'll start reaching out. Chris, we good?
Okay. Real quick, there is some questions that came in, and because of the early session, one of the questions that came in is, what is the time frame for humans to reach Mars?
Okay.
I know you talked about like 2024, and he kind of corrected it to 2030. You want to talk a little bit about that?
Yeah, so SpaceX has pretty ambitious goals, and one of them is landing on the surface of Mars in 5 years, which is something that Dr. Robert Zubrin mentioned in the previous broadcast, that it's a little too far-fetched. And so NASA has plans to land years after, and Dr. Zubrin mentioned that we land in the 2030s, early 2030s, just because it requires a lot of money and a lot of new technologies that we just don't have. It requires developing a whole colony on the surface of Mars before humans arrive. Because of that, it's going to take a lot of launches, and we also, our launch window is once every 2 years. We want to have a decent amount of transit time to go to Mars. So, any other questions, Mr. McKinney?
They had a question about radiation, how it affects astronauts.
Yes, that's a really good question. So here on Earth, we're shielded by the magnetosphere, right? So Earth has an active core, it rotates, it generates basically a big electromagnet. And we're shielded by the radiation from cosmic radiation as well as solar radiation. This is the kind of radiation you get when you're outside in the sun and you get a sunburn. That's radiation. When you're nearby a source of fire and you feel that heat, that's another source of radiation. That's infrared, actually. And so when we go to Mars, it turns out that Mars inner core is slowly, or it's much cooler than Earth because it's smaller, so it cooled much faster, and it lost most of its magnetosphere, and so it gets bombarded by radiation from the sun, and that's why Mars is red, because of all the iron particles rusting on the surface. Now you know why it's red. And so you'll get a lot of radiation on the surface of Mars. It's as if you were in outer space without any shielding. You'll get skin cancer, essentially. And because Mars has 1/100th of the pressure that you experience here on Earth, you need to ensure that you have a pressurized suit, so that essentially your guts don't come out. And so there's a lot of bad things that can happen on Mars if you don't take care of it. So one is radiation, like I mentioned, and then another one is you need to develop your own food, and you need to be very resourceful. You know, if you drink water and then you expel that, you need to find a way to repurpose that water as opposed to throwing it out. And that's actually what happens in the International Space Station. It's difficult to say, but the astronauts in the International Space Station drink their own pee. I know it's hard to say, but but when you purify and when you clean it enough, it's just as good as clean water. Yeah.
I thought it was interesting too, talking about traveling to Mars. He kind of shortened the time frame. We thought it was closer to a year. He said it's really about a 6-month journey from Earth to Mars.
Right.
And, he also said that cost was about $500 million, which is less than what it used to take just to get a Challenger, off the ground and into orbit.
I think now we're at $60 million through SpaceX, maybe even at 40, because they're reusing the rockets, and that's why Elon Musk from the get-go decided it'd be best we repurpose the rockets, reuse them, and he's been doing that. I think we've repurposed 4 times. We're at the 4th time. So taking off, landing, taking off, landing, taking off, landing, taking off, landing. That's insane. Oh, my phone died. Let me jump back. Can you all hear me? Hello.
Yes,
Oh,
yeah. You're now on Daniel's, and then your other.
There we go. My phone was jumping in on Daniel. Sorry about that.
That's all right.
You mentioned that when they reuse them, they only spend whatever it costs to refuel, which is about 60,000. So
yeah,
it's essentially creating 60,000.
So when you reuse a rocket, you're not buying up a whole new rocket or developing a whole new rocket for $60 million, but rather the refueling costs are only $272,000. That was a few years back, so I'm sure it's much less now. Depending on where it is that you want to go, if you want to go to low Earth orbit or geosynchronous orbit, which is further out where the GPS satellites are at, or if you want to go to Mars, that takes a lot more fuel. So the idea is to develop reusable rockets so that we can drop the cost to go to outer space. Right now, it's about $10,000 a pound to put into outer space. And right now, it's around, I think it's less than $2,000. NASA, obviously, it costs a lot more for NASA to put hardware in outer space, just because they're a government agency. I used to work at NASA, and I know how bloated agencies can get, and it's pretty expensive, especially when you have a lot of contractors. And so that's why SpaceX coming into the game and dropping the costs by making sure that they're the ones that are producing the hardware in-house as opposed to contracting it out like NASA does, ensures that they're able to drop the cost of going to outer space.
Awesome. Another question came in, Alberto and Daniel. And this is from Jay Pena again. Y'all are doing great. Do you think if we go to Mars, we will be able to use bacteria as a benefit for humans, or will it become dangerous?
Well, I know that everybody usually makes a big deal about finding water on planets, and I believe they're possibly have found water on the moon. But the big thing with finding it on Mars, and now even better, the moon, is because we can split hydrogen from oxygen, essentially creating more fuel. And that's why everybody gets like super excited, because essentially instead of having to fuel it all the way from here, we can essentially refuel on the moon and refuel on Mars. And the fact of like different bacteria found on Mars and other planets is essentially very interesting. And we won't even know the factor of how important it is, because we can then understand different life, and by understanding different life, we can then potentially improve our own life by getting the benefits of that different bacteria and seeing how the growth is at a minuscule level that we weren't able to witness from our level, essentially, because we essentially came from a form of bacteria. So yeah, that is interesting from my aspect.
And then also there's the idea that, like Dr. Robert Zubrin mentioned in the previous broadcast, that life could have come from Mars and life could have seeded on Earth thanks to Mars. So Mars used to be like Earth. Mars was once a habitable planet. We've proved that with the Mars rovers that have been roving around previous years. And so there's an idea called panspermia, where an asteroid hits Mars and then rocks and debris ricochet off, and then they orbit around the solar system, and then they land on Earth, and then that bacteria can seed life on Earth if the circumstances are ideal, of course. And then, of course, over time, or millions, if not billions of years passed, and then Mars slowly died out because it lost its magnetosphere, its magnet, and that's what was shielding it from the radiation. And so what happens is it loses also its atmosphere because of all these the solar radiation. And so yeah, bacteria on different planets is super interesting, especially if you're a government agency, because we're trying to figure out if we are alone or not. And if we find bacteria or microbial life on Mars, that means that there could be life on other solar systems, other stars, other exoplanets, as they're called, which are planets that orbit, stars. In this case, other suns, much larger than our own. That's a good question. Thank you for that.
Awesome. Does anybody have any questions from the classrooms that are still participating? If not, I'd like to approach terraforming. We didn't really cover it this session, but if you want to maybe discuss either your own knowledge or go back to what Dr. Zubrin was saying from the first session about terraforming on Mars.
Yeah, so terraforming is quite interesting. Terraform, students, for those that don't know, terra means tierra in español, right? So dirt, soil. And we're trying to essentially convert Mars like Earth. And to do that, you need to first thicken the atmosphere, increase the density. So like I mentioned, it's 1/100. So right now it's the atmosphere on Mars is 1% of Earth's, right? So to do that, we would have to pump carbon dioxide and oxygen and a lot of molecules and particles into the air so that we can thicken it, so that we can get rid of our pressurized suit, right? To do that, we need to generate plant life, because plant life, what happens with plant life is it eats up all the carbon dioxide, and then it throws out oxygen, and that's what we breathe, right? And so that's what we have here on Earth, and we're great at messing up planets. We do that here on Earth. So what we do is we take fossil fuels and natural gas and we burn it up, and then that turns a turbine through steam that we heat up through water, and then that generates electricity, right? There's cleaner forms of doing that via dams, and like the Hoover Dam, and solar panels via solar energy and whatnot. But to terraform a planet, there's several options, right? One of them, like we mentioned in the previous broadcast, is to essentially nuke the polar ice caps, and that will kind of jumpstart the planet. But even then, that would not be enough. You're talking about a whole planet. Yes, it's smaller than Earth, but it requires a lot more than that. You need also to ensure that you have shielding from solar radiation. You need to kickstart the planet, and that's something that we currently cannot do. The only way to do something like that is if we, if we generate heat internally and kind of kickstart the core. We don't have the capability to do something like that. We don't need, we barely, we're generating energy through fossil fuels, through essentially old plant life and dinosaurs. So terraforming essentially converting Mars to look more like Earth. And to do that, we would need to create some kind of shield. There is one option though. So Mars orbits the sun just like Earth, a bit further away, of course, that's why it's colder. And that's why they say Earth is like not too hot, not too cold, not like Venus, not too hot, right? And then not too cold like Mars. And so we're in the it's called the Goldilocks effect, where it's perfect, where life can prevail. And so there's one option, the option of occluding, so we can put like large solar panels that can block sunlight that's hitting Mars, and maybe at a reduced rate, and that will essentially drop the amount of radiation that's bombarding Mars. And in doing that, you can sprout life, plant life, human life. So that's one option. There's another option where we live inside of biospheres, and these are large geodesic domes where they're underground or they're on top, and we have plant life and organic material that's covering the surface of that, and that is what receives the radiation and doesn't penetrate and hits the humans inside the biospheres. But that's more closer to home. But yeah, terraforming is very difficult. If you guys have seen the series called The Expanse, it's a really good series. I suggest you watch it, and it talks about that. And there's actually one of the factions that lives on Mars. Is there any other questions, Chris?
Nothing else has come in via chat. And let's give one last question to anybody that's still participating.
Students, any other questions you might have?
Venus class is coming in. Yes, no. Looks like United South is waving at us.
So students, I know some of the conversation that Dr. Robert Zubrin had with us was somewhat high level. Not to lie, it was pretty, he went into like the chemistry behind a lot of it, a lot of the different topics. His background is in nuclear engineering, so he's an expert in developing rocket fuel. And so keep this in mind. Think about what it is that you would like to do for the rest of your lives. Do you want to pursue a job that will go by the wayside, where either robots or automation or artificial intelligence takes over, like Dr. Robert Zubrin mentioned? He mentioned that back in the day, there used to be folks that would operate elevators. Now those don't exist. There will be even folks as well that open the doors. Now we have, we walk into a supermarket and, we have these automatic doors that open and close. That's like straight out of Star Trek. We also have 3D printers, and we have a lot of other hardware that has replaced folks, have replaced the working man. So keep that in mind and pursue jobs in STEM, science, technology, engineering, mathematics. These are high-paying jobs. These are jobs that are future ready. So ensure that you pursue jobs that will exist when you graduate high school and pursue that career path into college.
Heriberto, Daniel, guys, thank you so much again for helping set up Dr. Zubrin to join us today and share his extensive knowledge. I'm going to go ahead and kind of wrap this session up so I can get this recording out to the many schools that couldn't participate. But I do appreciate those that did, and for bringing questions to him and kind of putting South Texas on the map to Dr. Zubrin. And it was nice that he mentioned Brownsville and SpaceX, and she brought that up the first session and kind of brought him in the loop. It's a great day. I wish everybody a very happy Thanksgiving break. Much deserved.
Yes.
Everybody's off next
Gobble, gobble.
Yeah.
All right, guys. Have a good one. Enjoy the rest of your day and happy weekend.
All right.
Thanks, Chris.
Yes, thank you very much. We'll stay in touch.